I think we had made it to maybe here, the one you can't see on the board. I haven't turned on yet. I think this was the slide that we ended with, the one that said perfectly the ranges of elasticity, perfectly inelastic and perfectly elastic and unit elastic. I think that was the last one. I did just put up this morning the next set of slides, the utility and consumer surplus stuff. I know you probably didn't get a chance to print it, that's fine. Probably won't, we may get to it today, we may not. We may just be able to start it briefly. We should be able to go through elasticity today easily enough, and then start that other series. But don't worry about it if you didn't get a chance to print it. I just did it this morning. It's actually a number, about 18, 19 slides. So it's quite a few of them. All right, so this was the slide we ended on. We talked about how when we calculate the coefficient, what does it mean in terms of consumer responsiveness? If it's inelastic, remember it starts with an IN, so it's going to be unresponsive. So that's how I keep it in my mind. I'm remembering it with the first, that prefix, or what is that called? I'm not sure it's a prefix, but the letters IN synonymous or correlated to unresponsive. If it's elastic, then it's just responsive. Consumers are extremely responsive to price changes. And if it was equal to 1 when we calculated, which is the one we did do, the response is just equal to the price change. Here's some estimates in the real world of some elasticities, the coefficient that was calculated. The top group is the inelastic items, the ones that have an unresponsive behavior to prices. In other words, you're going to buy them no matter what. Eggs, beef, gasoline. Now, stationery is kind of an odd one. I didn't think that would be as unresponsive, but maybe the stationery is a broad group that denotes paper, like school book, lined paper, or copy machine paper, or something like that. And of course, you probably wouldn't care too much. I shop around for computer paper. I mean, if we buy it, Walmart's the best place to get it, I think. The least expensive. But the other ones are definitely necessities. You're not going to really shop around a lot for that stuff. You're going to pretty much take the price of what's there. Certainly, if you go to convenience stores, you're going to pay a little higher because of the convenience of buying it quickly and getting into and out of the store. Elastic, the ones here listed, housing, meals, restaurant meals, airline travel, foreign travel, they're all over 1. And so if it's over 1, the coefficient, you're going to be more elastic, more responsive to price changes. Certainly airline travel. I booked a flight to Boston for the summer, and I was shopping around. I probably needed to look again this morning because what's the best time for airfares?
Wednesdays?
Tuesdays and Thursdays.
Between Tuesday and Wednesday at 1 a.m. So 1 a.m. this
They said
morning,
21 days.
airfares would go down during those 2 days, and I went ahead and did it yesterday though because I did not feel it was going to go that much further to Boston. But I shopped. I'm a vacation traveler. I'm not a business traveler. Business travelers that travel Monday through Friday, they don't care what the price is. They're going to book the flight. Who's paying for it? The company, or getting reimbursed. So anyhow, those are definitely elastic, very responsive to price changes by consumers. And again, the coefficients would be less than 1 if it was inelastic and greater than 1 if it was elastic. Here's some shapes of some demand curves and the elasticity relationship. If the demand curve. These are demand curves. This is the demand curve. It's horizontal. It's for one farmer's wheat. This is the price and the quantity. So if it's horizontal, it's perfectly elastic. Perfectly elastic. Very, very responsive to price changes. Okay. If it's perfectly vertical, like the one in the middle, it's perfectly inelastic, meaning unresponsive to a price change. And this is the example of the demand for a diabetic. The quantity of insulin. They need it. It's a necessity for a diabetic. And so they don't care what the price is per dosage. They've got to buy it. They've got to have it. It could be low, it could be high. They still got to have the quantity that they need to survive, function in life. And then the ones on the right, there's a mix there of different shapes of the demand curve. The one that's kind of curved and bowed, I don't really say much about, but you can see there's two other ones there. The D1, that's a little steeper. Now which one, would that be closer to inelastic or elastic? The D1, the one that's a little bit steeper. This one?
Inelastic.
Inelastic.
It's going to be closer to inelastic because it's kind of almost, not vertical, but you could tell it's a steeper curve. So that's a more inelastic demand. The one that's D3, this flatter looking one, certainly closer to this one, the horizontal, and would be more elastic in nature. Then the one that's curved is, I don't even discuss that one too much. Don't worry too much about that. But the closer it is to vertical, it's inelastic. Here's another picture of it. We're going to actually do the calculation here so you get another practice problem on it. The numbers. I'll go ahead and put up the numbers again. It'll work on this board. So here's the price and quantity. Now this is a graph, but I'm going to take the data from the graph. The price is at 90 cents. It went up to $1.10. And from 90 cents, it was at 1,200 items. What is this? Apples. Apples per day, and 800 items at $1.10. So, and that's letters, points A and B on the line. So what I'm going to do is calculate the coefficient, elasticity coefficient between those 2 points. It tells us that it's 2. Okay? It's already telling us that it is 2. I want to confirm it though. We're going to use the coefficient formula, which is the midpoint method we had the other day. Just again, another practice because you got to do this on the test. What you'll do is take the change in Q. Remember I said I like to do it this way. And you'll divide by the sum of Q1 plus Q2 divided by 2. And then the change in P divided by the sum of the prices. And divide that by 2 to get the average. So again, this is the midpoint or average method. So just plugging in the numbers from over here, the change in Q was how much?
2.
The difference between the two is 400. The quantity added together and divided by 2 is an average. What is that?
1,000.
I hope you can do this stuff in your head. But you're allowed to use the calculator if you need it. But I just think these numbers should be easy enough that you can do it. I used to kid my daughter. Well, I used to kid him. I always give him a hard time about being able to do something in your head without the calculator. You should be able to do that. Those things. You need a calculator to average that. I don't know. You don't have to be a math wizard. It's just add and divide. And you don't have to go out and buy a $100,000 calculator or a $100 calculator. Just go buy something that's cheap, you know, a little dollar store one. You can't read the signs. All right, so the difference between the 90 cents and $1.10 is 20 cents. Okay, that difference, change in P, and then the sum of the two divided by 2 The midpoint of that is $1. So now this is the numbers we have. On the top, 400 divided by 1,000 is, as a decimal, I'll go ahead and just put it down as 0.4. That's what it would be as a decimal. And then the 20 cents divided by $1 would be 0.2 as a decimal. And dividing that into 0.4 gives you the coefficient of 2. So it did work out to be what it said. Between point A and B, the coefficient elasticity of demand was 2. A 20% increase in price, and that's what this is, a 20% increase in price generates a 40% decrease in the quantity of apples demanded. So between points A and B, we found the coefficient to be 2. If we had other points on the line, like if we had a point down here, we could do it between points A and whatever point that would be, and it was going to be different. The coefficient is going to be different. Or on this side, it's going to be different between two different points, the actual number. We'll do that in a later problem. Actually, we'll do it again right here too, real quick. There's 3 different ranges of the demand curve. There's the unit point, which will be somewhere in the middle. I'm going to guess it's going to be right around here. Okay, because it's going to be between 5 and 6. And this is something like that. That's going to be my unit point, where the unit elastic amount is going to be equal to 1 when we do the coefficient. We can go ahead and do that real quick. Use this formula again. I'll kind of expedite it a little bit. The change in Q is between 110 and 120. I had to put the, actually it's not 110, it's 100, isn't it? That should be 100 there. So between 100 and 120, the average change there is 20 divided by the average of the 2, would be 110. And then between the 5 and the 6, the price there, the average is 5.5. And actually the change, I'm sorry, I got it backwards. That's on the bottom. 1 is the difference, and then the 5.5 is on the bottom, because that's the sum and the midpoint of it. So you've got the same on both top and bottom. I think this ends up being 0.222. This is 0.222, and that's equal to 1. So there's where we get our elastic, unit elastic coefficient equal to 1. And then from the rest of this particular demand curve, this range from the point, unit point here all the way down is all going to be inelastic, which will be less than 1. And if we wanted to try 2 points there, we would get it to be less than 1. It's going to be 0.8, 0.9, 0.7, something like that. It's going to get smaller as it gets further away. It may start out to be around 0.9 in here, and 0.8, 0.7, 0.6, 0.5. It's going to get lower, smaller and smaller the further you get away from it. Above this is the elastic range, and it's going to get bigger, 1.1, 1.2, as you go further and further up the demand curve. Again, you could take 2 points and you could actually calculate it just like we did to confirm it. Now, we talked briefly, the other day we did, about how and why products tend to be more elastic and tend to be more inelastic. I think I mentioned the very first one. There's 2 slides here, back to back. This slide is about inelastic products and services, and the next one is elastic, and they're just the opposite of each other. So I might bring up the examples that correspond to elasticity when we're talking about this one. Now this one's inelastic. The determinants or factors that will cause products to be more inelastic are first, the good is a necessity, or the service is a necessity. And you need it. You need food. You need shelter. You need gasoline. Those are broad items that are basic necessities of life. And so you're going to be unresponsive to a price change. So when prices go up, you're going to say, well, gosh, I don't like that, but I'm going to have to pay for it. So necessities versus luxuries. Now, when I say luxury, I don't mean yachts. I mean things like TVs or appliances, things you don't buy every day, and you don't need a TV per se, or a computer. You know, you can get by in life without it, I guess. The second item is the shorter the adjustment time, meaning you're not going to have much time to think about it. I gave a silly example in my other class. Suppose the college, a week before school started, announced that your tuition is going to go up by, I don't know, 200%. You were going to pay 200% more than you normally would pay for tuition a week before school started. You don't have a lot of time, do you? You don't have a lot of time to adjust. In other words, you're going to be angry, but you don't have a lot of time to go somewhere else. Grovel and end up throwing the credit card and pay for it. If you had more time, like we announced it 6 months earlier that we're going to have a 200% increase, then you had more time to adjust. Either you decide to go somewhere else, or you work a few more hours to pay for it. So you had some time to make an adjustment. You don't have a lot of time, you end up, it's very unresponsive to the price change, and you're going to pay whatever pretty much you have to. If there are a few good substitutes, if you don't have a lot of good substitutes and it's the only game in town, or the only item on the shelf, there's not another substitute or close substitute, again, you're going to pay the price there on that one. You're going to be unresponsive to the price change. If there are a lot of good substitutes, the opposite of this, it's very responsive. You're going to say, well, you got that price there, I can go over here and get this. It's just the same. Fourth one there is the more broadly defined the market. I mentioned the word food. That's a broad word. People need food to survive. Another less broad word in the food area is cereal. Food and cereal. Cereal is still fairly broad, because then you could break it down to what kind of cereal? Raisin Bran type cereals, or cornflakes type cereals, or the sweet stuff. The more broadly it is defined, the more unresponsive you are to price changes. I just need cereal. I didn't say what kind. I just said cereal. So when you say broadly defined market, I'm not going to worry too much about the price there. It will be very unresponsive to the price change. But if I'm looking at a specific kind of cereal, a particular, like granola, organic, it's going to be pricey, more than likely. And I'm going to be concerned, I don't want to get it here, I'm going to get it at Walmart. The last one here, when it's a small portion of your budget, if it's something like a canister of Morton salt, do you care what the price is? You know what I'm talking about, right? The round canister of salt that you go in, you just need it, you go pick it off the shelf, and you buy it. It could be 79 cents, it could be $1.19, I don't know. I really don't. You don't buy it that often. But I don't care. I'm just gonna buy it because I need it and it doesn't break my budget. It's a small portion of my budget. Now, the opposite of that is when the products are elastic, and if a portion of your budget is, I'll go down to the bottom here, it's a greater the portion of your budget. In other words, if I'm looking for a car, and it's a $20,000 car, and it's going to cost me $350 a month payment, I may not be able to afford that. So I got to shop. I'm going to go back down to a $15,000 car, and my payment will be $250. I'm going to do that. So I have to be very responsive to that price change. It's a bigger chunk of my budget. But small, cheap things are not, no big deal. All these were the opposite of what I talked about. The luxuries, like TVs and that, you're going to be responsive to prices. The longer the time period, you're going to be responsive because you're going to now change if you need to. So these were all the opposite effects of the inelastic determinants, but these are the elastic determinants. All right, so now we kind of get to what I guess the real purpose of this measurement is. What is the, why do we even concern ourselves with elasticity of demand? Why do we calculate this? If it's less than 1, it's greater than 1, or equal to 1, well, who cares, right? Why do we use it? Well, what it does, it allows for the manager or the owner of a business to be able to determine whether or not to raise or lower prices, because it relates to revenue, total revenue. Now, I know we haven't talked about total revenue yet. We will get into that at a later point, not this next chapter. It's about 3 chapters away. We get into the revenue streams. And if you've had a little bit of accounting, you may know some of this already. But revenue is simply the price times the quantity. That's all it is. That's the formula here, P times Q. The law of demand tells us that the quantity falls when the price rises. So what is the optimal price to maximize total revenue? Optimal price is the unit elastic point. I forgot to edit this next sentence. At any higher or lower price, I probably should have you put that too. I did it last semester and I forgot to do it again. Put /lower. At any higher or lower price, total revenue is decreased. So the price, when we find it to be equal to 1, that is the most optimal price to maximize your total revenue. Next slide, I believe, is the one with the table and the picture of the graph. And it shows what this represents here. I think it's VCRs, believe it or not. No, it's not. It's airline tickets, air travel. This is a complete table for the price and quantity, just like this. And then on the far right, the third column on the right is revenue. All that was done to get revenue is to multiply the two together to get revenue. P times Q. So the revenue, as you can see, this is again, now the only thing about this table is it goes backwards. It starts at the high price and goes to the low price. And the quantity is low and goes to the high. So it is inverse, it does go in the opposite way, but it doesn't go from low price to high price, so it's just reversed. But at the high price, as you see here, revenue is doing what? 200,000, 360, 480,000, 560,000, 600,000. But then when it gets to 500, it starts to fall, starts to go back down. And the prices are falling, the quantity's going up, but the revenue is still going down. And couple of graphs on the right, the one on the upper portion, I know it's small print, but the one on the upper side there is the picture of the demand curve. So what this line is these points plotted. So this was 1,000 and 200. This was 900 and 400. 800 and 600. So just point the dots that are pointing the coordinates and then connect it, and there's your demand curve. Then it also has, like the previous couple slides back, the range of inelastic and elastic. And again, this point about right there is the unit point where the E sub D was equal to 1. And then anything up above it was elastic, where it's greater than 1, and anything to the right of it, below it, was less than 1, if we do the coefficient. Then the one on the bottom is a different looking curve. We haven't done this. And what that curve represents is the graphing of the price, this column, and the total, actually, I'm sorry, it's the quantity in the total revenue. Okay? So you're calculating still the quantities on this horizontal axis. So at 200 tickets, right there, 200 airline tickets sold, the revenue was 200,000. This is in hundreds of thousands of dollars. So it's 200,000. At 400 tickets, the revenue was 360, so about right there. At 600 tickets sold, 480, so about right in there. You plotted all those points, and you got up to the pinnacle here, about there and there. You had two 600 dots, and I might be off a little bit, but then you connected it, and you had this little humpback looking curve. As the price was falling, it's falling the whole time, but in some sections, the revenue was rising, and in some sections it was falling. The downward slope on the other side. So what I did is what you have to do is, I think on the next slide, there's kind of a summary of this. What does it represent? Over the elastic range of prices and quantity, the relationship between price and total revenue is indirect or opposite. Over the inelastic range of prices and quantity, the relationship is the direct or the same. So I've got another kind of way to, it's not a special way, but just a using up arrows and down arrows again. So let's take the inelastic first. If the product is inelastic, and I'll go back to the table. I think you can see it from the table. If the product is inelastic, now you notice the color? They got different colors. Mm-hmm. The lighter colored tan here corresponds to the lighter side over here, the demand curve, and also to this right side of this humpback curve of revenue. So this section is the inelastic section. Okay, so that's where the demand curve, or the area color was lighter, and revenues were falling there. So when the price, so you just take this, let's say if price is falling, what is total revenue doing?
Rising.
Price is falling.
Rising.
What's it doing?
Falling.
It's falling. Total revenue is falling. If price is rising, now this would go, you go this way now, you gotta go the other way. What's revenue doing?
Rising.
It's
No.
rising. Again, you're only looking at the inelastic region. And I know it's inelastic, it kind of told us because the E sub D would be less than 1. If we did any of these points on here and did the calculation, we'd get it less than 1. Okay? So we know that it's an inelastic region. So that's the relationship, and that's kind of what this sentence says, the second one here. Over the inelastic range of prices and quantity, the relationship between price and total revenue is direct or the same. That's what it's saying. Price and total revenue, they go in the same direction, as long as it's inelastic. That means if it's a necessity, gasoline, price goes up, guess what? Those gas station owners, their revenue's going up. If they drop the price, their revenue's going to fall, because people, they gotta have it. So it's going to increase their revenue. The other one here is the opposite. This would be the elastic region of those kinds of products that we're going to shop around for. If the price falls, go back to the table, the elastic region is the darker brown color. So if the price is falling, what's happening to revenue?
Increasing.
It's increasing. If the price is, price is rising, what's happening to revenue? Price goes up, and this is the darker region, 6 to 1,000, the revenue is falling. Revenue is falling. So what the statement said in this first bullet point, over the elastic range of prices and quantity, the relationship between price and total revenue is indirect or opposite. It goes in the opposite way. And this is the one I wanted to mention about how if business owners knew this, and they knew their kind of product, then they could raise revenue by lowering the price. But sometimes business owners are hard-headed, and they don't understand the concept of elasticity, and they don't understand whether the product they sell is elastic or inelastic. I always bring up a few examples. One is go to a Rays game or Bucks game, whatever, professional sports game. What are concession prices like?
Through the roof.
They're through the roof. I mean, they're ridiculous.
Movies.
The incentive by you as a customer is that you don't want to buy, or you try to sneak things in. You have an incentive to cheat, to get things in. I know they check bags and all that. But what they're banking on is a little bit different factor that you can add to it, is that you're a captive audience. You're there. They know you can't leave to go get something, so they are banking on the fact that you're going to probably buy their high-priced bad food,
At least one time.
and beer and whatever else. But if they, and this is what would happen, now they think it's inelastic. That's what they must think. That the products that they're selling, because if they raise their, let's say they come out and announce that the concession prices are going up by 25% this year. Everything at the concession stand. Prices are going up. They think that this is going to happen because they think it's an inelastic type of good, meaning people are unresponsive to a price change. They don't care, I'm going to still buy it. I don't care if it's 20 bucks a cup of beer. I disagree. I think at some point people will decide, the heck with that. I am not going to drink anything. I'm going to sneak it in, or I won't drink it all. I'll wait till afterwards, or drink before, whatever. And they raise their price, this is going to happen. Their revenues are going to fall because people are responsive to the price change. You can't go too far. But they're banking on that captive audience, that they realize they got you. Like going to Disney World, you got to kind of buy, but they have there. So that's kind of the relationship. Another example I give is sometimes it's the perception of individuals, people, and how much you value a particular good or service. Everybody will be different. So I use the example of getting your teeth cleaned. Many of you value it as a necessity. I do. and I will get my teeth cleaned every 6 months, which is what they recommend, I believe. But some of you won't value it that way. You don't value it as a necessity. You value it as kind of a, not a luxury necessarily, but just something that, well, I don't need to do it. Okay? And maybe every 2 years I'll get it done. But I value it as a necessity. Not everybody's the same, though. And if I value it as a necessity, this is kind of what's going to happen. So the dentist raises his price. Now, if I like my hygienist, and I'm loyal to her or him, yes, there are some hymns, total revenue is going to go up. But if people don't value it that way, and they think it's something I can live without it for a couple of years, that when they raise the price, total revenue is going to go down. Dentists don't understand this. This actually happened. This actually happens a lot. Dentists will think that they can raise the price on something and go up, from $50 a teeth cleaning to $150. Well, people will shop around. They'll say, "The heck with you. My hygienist isn't that good. I'm not that loyal. I'm going to go somewhere else." So this is what would happen: is if you raise the price, revenues fall, and that's not good. But if they understood that, if they lowered the price, revenues would rise, because then people would come to get their teeth cleaned more so. Another silly example I gave was I went to the Little League World Series many, many years ago. Actually 1997. So gosh, that was 17 years ago now. Believe it or not, there's no admission price to that little stadium there in Williamsport. It was free. Now, that was in 97. I think it still is that way. Little League is an organization. It's a lot of things that are volunteer workers that work there. But free admission. And I think it's probably still that way. What really surprised me was their concession prices. You'd think because of free admission that they would have high concession prices. They didn't. It was really cheap. 50 cents for a bigger drink than that. 50 cents for a hot dog. And, just really, I'll bet they sold, I bet they just killed it on the concession. Because they realized that people aren't going to be there and be able to spend a lot of money. So anyhow, so these are a couple of examples. Here is just a summary. I'm trying to erase this without destroying the board. If demand for a good is elastic, which means that the coefficient is greater than 1, an increase in price reduces total revenue. So that's kind of what I'm doing here. In this case, the quantity effect is stronger than the price effect. This might have been what was in your book. Yes.
It's when you say perfectly inelastic or perfectly elastic, is that just the same as elastic or regular elastic, or?
Perfectly inelastic means it's perfectly vertical, the demand curve. Most often you're not going to see that.
Okay.
You're going to see a steep demand curve in that case, kind of like that, but not perfectly vertical like that.
So there is a
perfectly elastic is horizontal. What this is really summarizing what I have written here with the up arrow, down arrow thing. If demand for a good is inelastic like this, price elasticity is less than 1, a higher price increases total revenue. So a higher price increases total revenue. So a lower price decreases it. And if it's unit elastic, the change is exactly, they offset each other. The sales effect and the price effect exactly offset each other. All right, so let's move into the second type of elasticity. I told you the other day that most of the elasticity discussion centers around demand. Well, here is the one a little bit about supply, about 2 or 3 slides of this. Supply is the behavior of sellers and producers. And as you can see, the formula, and we'll use the midpoint method again, but the formula is the percentage change in quantity supplied. So instead of being something, this was the apples here, this would be quantity supplied instead of quantity demanded. If the price goes up, then the quantity supplied is also going to go up. But it's going to be the percentage change in quantity supplied divided by the percentage change in price, and you would use the midpoint method. It answers the question, how responsive are producers of this good to price changes? How responsive are producers of the good to those price changes? Now, many times, there's only a couple of factors and determinants with producers. One of them has to do with time. And I think you can kind of see these determinants and the flexibility that they have. Determinants of the price elasticity of supply is how quickly producers can adjust its output. So again, it talks about time a little bit. But they got to be flexible. If quickly, the elasticity of supply is elastic, which would mean it would be greater than 1. So in terms of the coefficient calculation, if it's greater than 1, it's elastic. If it's less than 1, it's inelastic. Same as demand. And if it's 1, it's unelastic. Same concept, same calculation. But if it's a if they can respond quickly in an easy manner, the elasticity of supply is elastic, very responsive. If it takes time and they can't adjust their output too quickly, then it's going to be inelastic, less than 1 in the calculation. Time and adjustment process. Often firms have difficulty increasing the quantity of the product they supply during any short period of time. So they have a difficult time doing it. What other factors? The availability of inputs. The price elasticity of supply tends to be large when inputs are readily available. It means greater than 1, and can be shifted into and out of production at a relatively low cost. It tends to be small, meaning that it's less than 1, when inputs are difficult to obtain. Very inelastic. Again, that time element. So this is kind of repeating the previous slide. Price elasticity of supply tends to grow larger as producers have more time to respond to a price change. This means that the long run price elasticity of supply is often higher than the short run. Now here are some, the shapes. Again, I think it's the next slide. The shape of the supply curve depends primarily on the length of time being considered. And we don't talk about, well, I don't want to say a whole lot about this yet because we do talk about it in 2 chapters from now on the cost of production. In the short run, at least one of the resources used in production cannot be changed. That's what the short run means. And we'll hear it again. I mean, I'll have it up again. In the long run, the firm has long enough time to change everything, whether it be 5 years or 50 years or 5 months. And they have, depends on the business. Certain businesses, the long run is much longer. Certain industries, like the car industry, it's a longer horizon time frame for the long run. Here's some shapes and some examples, and they're using the midpoint method. So the summary of price elasticities of supply. This one is the supply is elastic. So that would be a coefficient greater E sub S is equal, but greater than 1. E sub S is greater than 1. Here's the numbers. We can kind of put it in here. Price is going from 20 to 30, and the quantity goes from 16 to 18. No, 28. All right, so there's the numbers, and we could do the calculation real quick. E sub S, change in quantity supplied is 12. The average of the two, add these two. which is 44, right?
Yeah.
Yeah, which the average is 22. And then the change here is 10, and the average of the two is 25. So I don't have my calculator. 12 divided by 22 is what? Anybody got a phone? Yeah, let's use a phone today. No phones on the test. Put the calculator.
How far do you want to go?
12, no, I don't care. 12 divided by 22, what? Point what?
154, and it's repeating a lot.
Okay. What's this one? 10 divided by 25, that's 4.4, isn't it?
Yeah.
So 0.4 into that equals 1 point something. I don't know. It's got to be 1 point something. 1 point what?
1.63.
63, so I just ran.
I mean, 36.
Oh, 36.
Yeah.
So 1.4, roughly. So it's over 1, greater than 1. It's elastic. And you can see the shape is kind of a normal shaped supply curve. What about the one, this middle one? That looks very vertical, doesn't it? Or kind of steep, which would mean more inelastic. So it's got the same kind of shapes that the demand curves had. If it's horizontal, it's closer to elastic. If it's closer to vertical, which that middle one is, it's going to be more inelastic, unresponsive to price changes. And we could do that, and it's going to be less than 1. The numbers are a little bit different there. Price goes up from 20 to 30, and it only went up from 16 to 20. So the numbers are a little bit different. The one on the far right, it equaled to 1 when I did the calculation. Exactly a 40% increase in price caused a 40% increase in quantity supply, resulting in an elasticity coefficient of 1. And that's kind of again, a fairly normal shaped supply curve. All right, there's another measure of elasticity. This is the last slide. The income elasticity of demand. And what this is the coefficient that determines the responsiveness to income. How demand, your demand, is responsive because of what you make, how much income you have. So I only spend just one slide on it, but you can see the definition. It measures how a change in income affects your spending. So the percentage change in quantity demanded, which we can label it here, percentage change in quantity demanded would be divided by not price, but percentage change in income. We'll use capital letter I. Okay. So our table of data would be different. It wouldn't be price here. We would not have price. We would have to have income. Of course, we don't want supply either. We want quantity demanded. We have to have income. So I'll just make something up. At $10, say you make $10 an hour, and you get a raise to $12 an hour, your income. When your product demand, when you say, okay, at $10 an hour, I'll demand 20 of them, and at $12 an hour, I'll demand 30. What does that mean? The more you make, the more you spend. That kind of sounds like a normal good. We had that before. Goods for which the income elasticity demand is positive, that is, goods that consumers demand more of when their incomes rise. But the inferior goods, those we had before, we talked about this before, like ramen noodles, consumers will substitute away from these goods if their income permits it. And it means that if they get a raise like this, it's going to go from 30 to 20. Or we'll just change this, we'll make it go down to 10. Okay, because I'm not going to buy those anymore. I make too much money. Okay, it doesn't have anything to do with the quality. It just has to do with you'll shift away from those when your income does permit it. But if you wanted to do the calculation, you could do the same thing. Now, I don't ask you to do the calculation on the test, so I really don't want to, do one, but if you could do it for these two numbers here. The only thing that's different with this is that it's going to be a positive number. It will not be, and it will be a negative one too. They will add, if it's a negative demand elasticity, then it's inferior. If it's positive, it's normal. So I don't really want to do it because I don't require it on the test. Okay. Just wanted to bring it up because there is a different measure, really. Utility, consumer, producer surplus. The title of the chapter, I think, was Utility and Consumer Decision Making. I'm not sure exactly. Sometimes they change the titles. This is chapter 6. Consumer Choice and Demand was the title of the chapter. The beginning part, or the first 6 or 7 slides, are about mainly utility, something we've actually talked about before. Remember I said back in the demand material where utility is synonymous with the word satisfaction or enjoyment. So utility means how much satisfaction you receive from consuming goods and services. It's a sense of pleasure that comes from consumption. The assumption here, though, is that tastes are given and relatively stable. Yeah, big assumption, I got that. Okay, but in order to kind of keep the concept reliable, you assume that people's tastes are given, and you like everybody likes red meat, that kind of stuff. The principle of diminishing marginal utility, this I gave you an example on also that day. Remember how the vending machine was a diminishing utility, and how if you go out to eat to an expensive restaurant, you wouldn't necessarily do it the next night because you consumed it once, you were very highly satisfied. The next night it may not be quite as satisfying. Although the food is probably just as good, you're just not as satisfied. You didn't enjoy it as much because you're paying a high price for it. Consumers experience diminishing additional satisfaction as they consume more of a good or service during a given period of time. That's what the law of diminishing marginal utility represents. So there's two concepts or two topics here, terms. Total utility is total satisfaction you derive from consumption. Again, the word consumption is you purchasing or eating. That's the total utility. Marginal utility is the change from total utility from a 1 unit change in consumption. And we're going to have some tables. I don't know if there's one on the next slide or not. Yeah, there is. This is the pizza. And I'll probably end it today with this one. I could not make this any bigger. I've done it, tried it. I probably just need to be a creaker. I like the graphs, but this is just small, I realize. But if you were able to print it, you can see it. This is total and marginal utility from eating pizza on Super Bowl Sunday. So this is the quantity of slices of pizza, and this is total utility, and this is marginal utility. Now you're probably saying, well, how do you get total utility? Who comes up with that? Well, it is kind of a nebulous concept. What are utils? They use the phrase utils. Just think of a unit. Economists use the units of measure. How much satisfaction does a slice of pizza give you? Everybody's going to be different. Some people don't like pizza, so that wouldn't give you any satisfaction. But the number of slices there is going up, but you'll see the total utility, the total satisfaction is rising, but it's beginning to level off. So you eat your first slice of pizza, and this first cell for the total utility is 20. So it provided 20 units or 20 utils of satisfaction. The second slice provided total of 36 units of satisfaction, total between the two, of the two. 3 slices provided 46 units of satisfaction. 4 slices provided 52. 5 slices provided 54. This is total now. On the 6th slice, it falls back down to 51. So you hit a threshold. Well, that is graphed right here. That's the graph that kind of goes up, then it starts to level off. It's not going up as fast because you're getting full. You're getting full, and then you don't want any more. So it's not providing any more satisfaction. That 6th piece starts actually goes negative, and you go, I shouldn't have eaten that last piece. But it does. It starts to diminish. Well, that's that humpback looking curve. Then all you do for the next column, the marginal utility, is just to take the difference between eating 1 slice and the second slice, the second slice and the third slice. So between 0 and 1, what was the change, marginal amount? 20. And they put it there on the cell. Technically, it should be between the rows, but using kind of spreadsheet here, it's hard to do. So they put it on the next row down. Between 1 and 2, eating between the first slice and the second slice, it provided an additional, the difference between 20 and 36 is 16. All I'm doing is taking the difference, and they put it on the next row. The difference between 36 and 46 is 10. The difference between 46 and 52 is 6. 52 and 54 is 2. Now if this one goes down, it should be negative 3. There's a little symbol in there, I got messed up, but that's a negative amount. Now that portion is graphed right here. This is the marginal utility line. As it starts up high at 20, goes to 16, goes to 10, goes to 6, 2, and then it's negative, negative 3. So the data in a table like this, I will have it on a test question. We actually extend this further with looking at decision making. Consumers will have to make decisions, but they'll be given their utils or units of satisfaction. Now I realize that in everyday life you don't have this table. You don't know what your satisfaction is. But some of you might eat 2 slices of pizza and it's diminished then, it's over. I don't want any more. Some of you might get to 10 slices before it goes like that. It just depends. Everybody's going to be different. But I know you don't have the data. So what we'll do is we'll stop here, and the next slide actually continues the discussion using decision making.